Hey everyone, before we get started, I want you to know something. In fact, I will ask you one question. This is a binary question. It's either you answer with yes or no. And in case your answer is no, please make sure that you pause this video right here, right now. Okay, so here's the question. Have you attempted exercise 5.3? If the answer is yes, please stay with us. Just take a look at what I did, what Luandile did on this exercise. But if your answer is no, I dare you to please pause this video, give it a try, and then later on, get back to. Okay, with that out of the way, let's continue. Here's exercise 5.3. Again, there's no asterisk next to the exercise number, so that tells you it's one of the simple exercises one can find on this chapter. Okay, so we are required to do conversion from kilograms to pounds. We've got to write a program that displays the following table. Note that 1 kilogram is equivalent to 2.2 pounds. Okay, so let's see. I've got this solution here. Okay, so here's what one would have to do to display that table. The first thing we want system.out.print is to display those column names at the top of the table, and it's kilograms \t pounds. Okay, once we're done doing that, again we know how many times we're gonna iterate, so it's better we use a for loop. Gonna start from 1 and then end at 199, right? Okay, so our for loop will simply look like this. Int I equals to, I know I'm not a huge fan of using indescriptive variables, but in this case I'll make an exception because there's it's gonna be a pretty short code, so it's not like that's gonna distract. It's not like that is gonna distract us in any way. Maybe down in our code. Okay, so here's the deal. Number one, we've noticed that since we've got a finite number of, since we've got 3 decimal points, it will be convenient to use printf. So the first thing I want to print I, and then I want to print I multiplied by that constant 2.2, right? Because 1 kilogram is equivalent to 2.2 pounds. Okay, so this is it, and right here we want to display the digits I, or the decimal number I. That's what that's the right term, not digits as in it's only 1 digit. Okay, it's decimal number I, and then we want to go \t. However, I'll use two I'll use two of them, 2 \t's, right, instead of 1, and you will see later on why did I do that. Okay, and then lastly I wanna let me leave one space after let me leave one space to the left of my number I'm about to print there, and go one space, and go 1 for the number of decimal points, then put in F for our format specifier. That should do it. Let's see what we get. Oops, of course I've got to add \n to go to the next line. Let's see what we have. Seems like we're getting exactly what we expected. However, before I mention this, take a look if we decide to remove one \t. If we do that, you see now our output is in the way we want it to be. Okay, so that's why I decided to use two \t's there. Okay, another thing, if you properly compare these two, our output here and this and what we have here as our sample run, they are slightly different. Why? There's a space preceding these two. If you had to think of these as two columns, right, there's a space preceding these two. I'm not talking about the space from there up to that point. Forget about that. I'm just talking about the space, this one here, this part, right, this part. And if you check it, this case, there's no space. Alright, there's no space preceding 437.8. I'm not talking about this space here. I hope everyone is clear there. So you can think of it as these numbers are shifted or perhaps adjusted to be on the right. If you look at these values for our pounds, however, ours are shifted to the left or are adjusted or aligned to the left. So we gotta take care of that. So that is where this comes into play. That is where this value for our format comes into play. You see, I want you guys to see the difference. Take a look if we put a 3, for instance, here. It simply says leave 3 spaces to the left of your value of this computed output here, of this computation or whatever you want to call it. Okay, so now let's check our output, how it's gonna look. Okay, it seems like it didn't do much. Let's try something like 5 spaces to the left. You see now this number here, it used to start right over there. Now it's shifted a little bit, however it's not in the end. I want it to shift towards the end of this. It has to be as close as possible to this S here, right? So it seems like we've got to keep increasing that number. So if we put a 6, let's try 7. Oh, it seems like now it went over to the point we want it to be. Okay, let's get back a little bit. If we put a 6, so we're saying 6 spaces to the left of this, of each and every one of these numbers here. Okay, let's see what we're gonna have. Boom, seems like we're getting exactly what we needed. See folks, that is precisely like this output here. Okay, I was just showing you guys the importance of using printf over print for properly displaying your output. That should be it for this tutorial, you guys. Again, you could have used the while loop, but a for loop is the better choice because you know how many times you wanna do this. I mean, a do while loop would do it too, but I mean, why would you use it? Because the do while loop is only used when one knows that there's something that has to be done at least once, and in this case I cannot think of anything of that nature. Okay, so that should be it, you guys. See you on the next one. Cheers. I'm going.